Hello Year 11 and welcome to our fifth and final video for our third unit here, linear functions. We're looking at conversion graphs today. Right? It's a funny thing with this topic, we seem to be working from harder to easier, right? I don't think these are terribly difficult things to work with. I think they're somewhat easier than what we've done before. But anyway, conversion graph, we use it, not unsurprisingly, to convert things, to convert between units like, say, feet and meters, or perhaps between different currencies like Australian dollars and US dollars or something like that. Okay, it is always an example. Well, these typically will be direct linear variation. That is, they are a straight line and they have a y-intercept of 0. And if you think about things like that, 0 feet equals 0 inches. Sorry, 0 feet equals 0 meters. 0 US dollars equals 0 Australian dollars. Right, but however much 10 Australian dollars is in US dollars, if I double that, if I double the Australian dollars, I have double the US dollars. We could use conversion graphs for other things that are not direct linear variation, such as converting between degrees Celsius and degrees Fahrenheit. That's not an example of direct linear variation. We could use conversion graphs for them as well, but mostly we'll see ones like this that are direct linear variation. And really they're fairly straightforward. All we need to do is to take the value that we know on the correct axis, right, and extend either vertically or horizontally until we hit the graph, until we hit the line, right, and once we hit the line we change direction and head directly to the other axis. So here's an example. This graph converts between feet and centimeters. If part A says Kylie is 5 foot tall, what is her height in centimeters? Right, I go along here. These are my feet. Here's 5. Right, I get to 5, and then I go straight up. Right, perpendicular to the axis. In this case, heading in a vertical direction until I hit that line. Right, I go up, 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 up till we hit the line. Right, we pivot there, and now we head directly across to our other axis. In this case, the vertical axis, until we get over here. Right, and reading those off, I'm looking at this and I've got 1, 2, 3, 4, 5 squares represents 20 centimeters, so each square must be 4 centimeters. So this is 144, 148, 152 centimeters. Okay, 152 centimeters. All good? Next up, a doorway is 85 centimeters wide. Convert this to feet. So now I need to go the other way. I go up here till we get to 85. Right now that's not exactly on one of these lines, so you can see it's a little blurry, but as we track along there we're sort of in between some of those grid lines, but we head straight across here until we hit the line, pivot there and go down until we hit that axis, and we need to carefully read off here. Now again, we've got 5 little squares, represents 0.5 of a foot. So each one of these must be 0.1 of a foot. So we've got 2.6, 2.7, 2.8 feet. 2.8. We can use this little symbol here for feet. The gradient of the line in the conversion graph is 30.5. What does this represent? Well, when we are dealing with direct linear variation, in fact, whenever we're dealing with gradient, this word per is a good way to give your answer. So it's going to be centimeters per feet, right? Because your gradient, remember, is your rise over run. So this is my rise, right? My graph rises 30 centimeters per foot. Okay, so we have 30 centimeters per foot. The conversion rate is 30 centimeters per foot, i.e. what that means is 1 foot equals 30.5 centimeters. Rightio, that's conversion graphs. That is linear functions. So just a quick recap there for conversion graphs. Right, find the value that you're given on the axis, move perpendicular to that axis, whether it's straight up or straight across, until you hit the line, and then pivot and head towards the other axis. Read it off there. Quite straightforward. That is conversion graphs. Rightio. Any questions? Save them up. I'll see you in class.